If this is really the beginning of a flip, what exactly will happen next? One man who may know is geologist Rob Coe. For 25 years, he's been coming to Steens Mountain in Oregon, a vast heap of hundreds of ancient lava flows.
"16 million years ago, there was a huge series of eruptions here. You can pick out literally hundreds of lava flows over on that wall. Each line delineates a different lava flow. It's over 3,000 feet of overlying flows.
What makes Steens special is that 16 million years ago, when this lava was erupted, the magnetic field was in the middle of a flip. Taking samples from dozens of flows all the way up the mountain, Rob and his colleagues have pieced together a detailed record of this magnetic reversal, although it's so surprising that not everyone accepts it.
What we found as it started to reverse was the strength of the Earth's field decreased dramatically by 80 or 90%.
The field started out pointing south, but as it weakened, the direction of the field began to change erratically. After 300 years, it had swung a full 180 degrees to point north, and the field's strength started to recover.
But it couldn't hold that polarity, and it fell back to reversed, and the intensity crashed again.
Once more, the Earth's magnetic shield practically disappeared, this time for 3,000 years. What was left was changing so fast that Rob found a flow that captured these wild gyrations even as the lava cooled.
And what we found was even harder to believe. The quickly chilled margins in the bottom and the top had one direction, like that of the underlying flow, and the middle portion had a direction that was 60 degrees farther away. It was just as though, while the flow cooled, the field had moved 60 degrees, which if you calculate it out, that comes to about 6 degrees of movement per day. If we were observing this with a compass, you would be able almost to see the motion with your eye. It was truly astonishing and extraordinary.
The lava layers of Steens Mountain suggest we could be in for magnetic chaos, with magnetic north changing from day to day. More seriously, for perhaps thousands of years, the Earth's magnetic shield will be weakened, something that will affect every person on the planet.
The intensity of the magnetic field will be weaker, maybe 10, maybe 100 times weaker than it is today, which means that more cosmic radiation will get through.
This basically opens our defenses so that solar and galactic radiation can hit the atmosphere directly. And this means that the radiation at ground level increases as well.
One estimate is that our overall exposure to cosmic radiation will double, and in some places it could be even worse. Today, the magnetic field focuses space radiation towards the far north and south, where few people live. But as the main field collapses, the weak field that's left will have a more complex structure. Instead of just 2 magnetic poles, there may be 4 or even 8, slowly moving across the Earth's surface.
The structure of the magnetic field won't be the nice, smooth, simple dipole structure that we have today, which tends to deflect charged particles, cosmic radiation, to the poles of the Earth. Instead, there'll be several poles all around the Earth, maybe close to the equator. And so not only will the field be weaker, the field will tend to focus cosmic radiation at low latitudes where most people live.
This unfortunately means more deaths from cancer. deaths. It's roughly 15 per million people per year. That is the amount of deaths we're talking about. And if you multiply that over the whole population of the Earth, that becomes a significant number.
It's impossible to know for sure, but the best guess is that every year 100,000 people would die from the increased levels of space radiation. But of course, this would still represent only a relatively small increase in the overall incidence of cancer.
So it's not going to be catastrophic. It'll be something to be concerned about, but it won't be a catastrophic event. And certainly by the time it happens, civilization will have figured out how to deal with it.
The field will come back. In the case of Mars, we know that the field will not come back, and it has been gone for billions of years, so the effect has been very, very serious on the Mars atmosphere. But on the Earth atmosphere, just a few thousand years of no magnetic field are not expected to result in a very large stripping of the atmosphere.
Scientists now know that the magnetic reversal that is inevitably coming will have serious consequences for our descendants, but it won't be a disaster for planet Earth. And as our children's children's children wait for north to become south, they may find that a world without a strong magnetic field has its compensations.
The great thing is that it would be possible to see the aurora just about every night, all over the Earth. So London behind me, for example, we might be able to see great aurora just about every night of the year, shimmering and moving in the sky as the solar wind hits the atmosphere directly, and it glows like a neon light.
Aurora would be very exciting. I can imagine a very interesting, dynamic magnetic field outside of the Earth during the next reversal.
I would love to see a reversal happen, but it would involve me living rather longer than I planned to, but that would be very nice. In fact, it's one of the great tragedies of life. We never see how these things work out.
I'd really like to know how it does it and why it does it, and when will it do it again?